Bismillahirrahmanirrahim. Okay, so we're going to continue with chapter 11 here. Okay, so we learned some rules about simplifying radicals. So we learned this rule, and it goes back both ways. There are other rules. Okay, there's one rule like this. Okay, this which you need to know: square root of a over b. Okay, if you have a fraction like this, okay, you can simplify it as square root of a over square root of b. Fair? And the same way it goes backwards, as I said, square root of a over square root of b equals, you can bring them under one umbrella like that. Okay? So, for example, if you have square root of 1 over 16, right? This is like square root of 1 over square root of 16. Right? So this is what? 1 over 4. Correct? Does that make sense? 1/4. Or if you have square root of 3 over 25. So this is square root of 3 over square root of 25. Right? And then this is, well, square root of 3 over 5. Does that make sense? So that's another rule that we need to know. Now, we talked briefly before about solving radical equations. So if you have square root of x equals 3, the way we solve this is by squaring both sides. Correct? So, and the square and the square roots, they neutralize each other. Okay? So this becomes x equals 3 squared is 9. Make sense? But we said the basic principle of solving radical equations is what? You have to do what to the square root sign? You have to corner it, right? You have to corner it. In other words, before you square both sides, if it's like this, square root of x, okay, plus 3 equals 9. Like this, okay? Now, you notice that I put a little hook over here, right? It's not by accident. A lot of mathematicians do that, okay? That's for emphasis, okay? So that people understand that you're emphasizing what? That the 3 is outside, okay? You could write it like this, square root of x plus 3 equals 9. But if somebody careless like this, you wonder, right? Do you understand what I'm saying? But if you did this, then you're saying, you're emphasizing that this is, you understand? So this little hook over, I nearly always do that, I really notice. So if you have square root of x plus 3, now this, the emphasis, okay, equals 9. So this, I'm clearly saying this 3 is outside. Got it? So when you have this, you don't square both sides, because that's trouble. Then you have to FOIL this. Then you have to do x square root of x plus 3 times square root of x plus 3, right? First, outer, inner, last business. You can do that too. And why make trouble when you don't need it, right? So the basic approach is you don't square both sides unless you corner the radical. You understand? Corner the radical. So what does that mean? That means you have to get rid of this 3. Okay? So negative 3 and negative 3 from both sides. Then you get square root of x equals 6. Correct? And then you square both sides, you get x equals 36. It's not plus or minus or anything like that. That's when you're taking square roots of equations. You understand? You follow? This. Got it? So the basic principle is you don't square both sides until you isolate or corner the square root sign. Yes, sir.
So what if on both sides of the equation there's a square root sign? Then what do you do with what's the point?
You skip the question. I'm just kidding. I'm just kidding. Otherwise, like this: the square root of x, his means like plus 3 equals the square root of 5. Yeah? Okay. So here, same principle. There's no x over here, right? You try to solve for x, right? So you want to square it so you get rid of the radical sign over the x. Do you understand what I'm saying? This is just a number. It's like pi. And you don't square a pi to make it like that, you know what I'm saying? You follow? It's just a number. You get it? So here, okay, let's do this one. See here, you do the same way. You subtract 3 from both sides. Okay? So then you get square root of x equals square root of 5 minus 3. Right? Okay, so now you have to square it. Right? You have to square both sides. Correct? So how do I square that? Like that. Okay, you follow? So this becomes just what? X, right? And some students do this. Okay, silly thing. They square both sides, and then they write square root of x. No, wait a minute. You square it together. It's still there. Yes, sir.
Can you just square 5, like, and then whatever you get, you just minus 3, subtract 3 from there?
Like over here, you mean?
No, before you do minus.
Before you do minus?
Yeah, before you subtract.
Okay, sure. Let's do it. So square root of x plus 3 equals square root of 5. So you want to square it right now, right?
Yeah.
Okay.
Just the 5.
No, you can't do that. That's will be hard because you can't do something to one side of the equation and not do it to the other side, because that is around. You follow? Okay. So then you do this, right? And then you square both sides, right? Okay. Then you get, here you get x. And then you have to square this whole thing, right? Square root of 5 minus 3. I'm just going to put it over here, right? Let's see. Square this and square this, right? How are you going to square that? You can just write it like this, right? But then, you know, that's not right. Okay, so what you do is you have to, okay, fine. And you say x equals square root of 5 minus 3 times square root of 5 minus 3, like this, right? Well, that's a binomial, right? It's like a minus b times a minus b, right? So you have to do what? You have to FOIL it. So we can do that. We know how to FOIL stuff. So first, that's this. So that's square root of 5 times square root of 5, right? So what's square root of 5 times square root of 5? Square root of 5 times square root of 5 is? Very good, 5. I know you're just testing me. Okay, 5. Did you get it? When you multiply 2 squared root, it's like the same thing. Square root of 5 squared. It's? Yes. So, do you understand?
Why is it 5?
Square root of 5 times square root of 5? Watch this. Square root of 5 times square root of 5 is square root of 25, right? Yeah? Any square root multiplied by itself gets rid of the square root. It's like squaring. What's square root of 5 squared? It's 5. What's square root of x squared? It's x. What's square root of y squared? It's y. So I'm running out of alphabets now. Square root of a squared. Here we go. You understand? If you square the square, that's the whole point. The reason you square is to get rid of the square root. You follow? Does that make sense? Okay? So first, square root of 5 times square root of 5 is what? 5. Outer, that's this. What's square root of 5 times negative 3?
3 times square root of 5.
Negative 3 times square root of 5, right? What's inner? It's negative 3 times square root of 5. What is that?
Negative 3 times square root of 5.
Negative 3 times square root of 5. And then the last one is negative 3 times negative 3. What is that? 9, right? Positive 9. Correct? Yes? Who's not following? Okay. You understand I'm doing FOIL?
Yeah.
Okay.
Oh yeah, this is a squared plus 2ab minus b squared.
It is, yes, but I'm doing it the long way. Okay, now you have this, right? You get so far understand this, right? But these are like terms, see? What's 3 square root of 5 plus 2 square root of 5? What is this?
They're not like terms.
They are like terms. Square root. That's 5 square root of 5, right? 3 apples plus 2 apples.
Oh.
Yes? You understand? Yes?
Yeah, negative 6.
Okay, so that's negative 6. Okay, right? So 5 minus 6 square root of 5 plus 9, right? Okay, now you can add these two, right? correct? So that's what? 14 minus 6 square root of 5. That's x. Do you understand? Okay, now you could say this. Okay, well, square root of x plus 3 equals square root of 5. What's square root of 5 on your calculator? It's like a decimal number. It's like 2 point blah 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 blah. Right? You can do that, but that's not cool. That's like, I don't know my math. I'm just going to use the calculator. You follow what I'm saying? You could do that, and you could subtract the 3 and square, and you get that. But this is like tells me, okay, you understand what you're doing, right? You follow? Okay.
What did you do before that?
Before what?
Before you foiled?
Before I did this?
Yeah.
Right here?
Yeah.
Okay. So let's do this again. Different example. 2. Square root of x plus 2, okay, minus 3 equals square root of 2. Okay? I can't square yet, right? Because the square root sign is not isolated, right? Correct? Now, see, the basic principle for solving radical equations is what, Omar?
You need to corner the radical.
You need to corner a radical. It has to be all by itself, right? And then you square it, right? You follow? Alright. Okay. You following this? You get it? So, see, it's like this. If you have x minus 3 minus pi equals 18, you can't square this until you get rid of this and you get rid of this. Do you understand? Then you get x, square root of x equals whatever, and then you square both sides to get rid of it. You understand? So the basic principle is you can't square, corner the radical, and then square. So you have to get rid of this and take this to this side, right? Okay. The way we do that is by adding 3 to both sides, correct? Alright, like this. Then you have x plus 2 equals square root of 2 plus 3. Everybody agree? Now, Uthman here wants to take this calculator. He's tempted. Alright? But, it's okay. He's trying to be good here. So then you square both sides. Do you understand? Because now the radical sign. Now he said, why do we square over the square root is over there? No, I thought you had to corner it. No, you don't have to corner that square root. You have to corner the square that has a variable in it. You know what I'm saying? Yeah, because you try to solve for this. You're not trying to solve for that. You get it? Okay. Alright, so we cornered it. Okay, let's square both sides now. Ooh, like this. Right? So then you get, what do you get? What do you get over here? X plus 2 equals, now you have to square this. Square root of x plus 3 squared, right? Huh. You have to square this thing, right? How are you going to do that? You have to do 4. You square one time?
No, you just write the same thing over and
Yeah, you foil it.
A squared plus b.
Yeah, it's like this. This one is this. A plus b squared is a squared plus 2ab plus b squared. But if you don't know this, you can just foil it. Okay? You will know this, inshallah. By the time you okay, you follow? That means, okay, I'm foil this. Okay, I'm going to foil this. Square root of 2 plus 3 times square root of 2 plus 3. That's what it means to square something, right? Multiply by itself, correct? So first means I have to multiply the first terms. Now square root of 2 times square root of 2 equals? Very good. We are making progress. It is 2. Okay. Now outer. That's this one and this one. What's 3 times square root of 2? 3 times square root of 2. Inner. 3 times square root of 2. Very good. Okay. Last. 9, right? Okay, now these are like terms, right? So these two are like terms that can combine. And these are like terms that can combine, right? So that's 11 plus 6 square root of 2, correct? You follow?
How'd you get 2 in the first?
Well, right here? That 2? When I foil it, first, that was the first term. You get it? When you foil this, square root of 2 plus 3 times square root of 2 plus 3. That first term are these two are the first terms, right? So square root of 2 times square root of 2 is 2. Right? Okay, because it's like square root of 4, which is 2. Yeah? Okay. That's how I got that. I got the 9. I added them together. I got 11 plus square root of 2. We're not done yet, though, right? Why aren't we done? Because we still have this on over here. This is over here. So it's x plus 2 equals all of that. You get it? So now we have to subtract 2 from both sides. And like this. This is gone. So x equals 9 plus 6 square root of 2. Does that make sense? Yes? Okay. Now, Usman, you might need smelling salts on this one. You know smelling salt. Ready? Now what? Abdullah. What's this? Square root of x plus 2. Okay? Equals square root of 3x plus 1. Now we have variables on both sides. What do we do?
You just bring one of the variables on the other side.
You say what? You want to square both sides?
No, you bring one of the variables. Wait,
No.
you either
You can just square both sides. Since both of them have
That's what he's saying. Is that what you're saying?
bring one
it
of the
says
x
to
on
bring
the
one,
other
it says to bring one of them, but you can't do that since you never added them. You can't just
What you really saying? You don't square both sides.
Yeah,
Okay.
basically.
See, if you bring this to this side, then you get x plus 2 minus square root of 3x plus 3 equals 0. Now you have to square both sides. You have to FOIL this thing. You understand? No, that's too hard. Here you just square both sides. Watch this. You got it? Then you get what? X plus 2 equals 3x plus 1. Then you subtract x from both sides, right? Because you have to bring them on the same side.
Yeah, that's what I was trying to say.
I knew it. And then you subtract 1. So 1 equals 2x, and divide by 2, x equals 1 over 2. You get it? Yes? Okay. Alright, Usman. This is a real test for you, okay? Now what do I do?
You add 3 also, and then you square.
This is a real test now. Abdullah, what do you think?
Get it in the corner.
But how am I going to both on one side?
Oh no,
No, I can do that. I can get both on the one side.
You add 3 and then you square both sides.
You add 3?
Yeah, and then you square both sides.
Okay, so add 3 on both sides like this. Okay, watch. Are you following this? Like, who's not following this? Raise your hand. Who's following this? Raise your hand. Okay. Alright. What do I do, Abdullah? What do you think? Okay, add 3 to both sides. Okay. Okay, now you get square root of x equals square root of 2x plus 5 plus 3. Now what? Now what? Square both sides? But then you have variables on both sides. Isn't you supposed to corner them?
Square, it's fine.
Huh?
isn't that what you're supposed to do?
But you haven't cornered the variables in this, you see? They're not. Don't you want to bring them together on one side?
No.
No. This is a different type of a question, okay? When you have only one, when it's like square root of x plus 2 equals 3, right? Then then you can do it that way. But when you have variables on both sides, what you do. It's a challenging, more trickier problem, okay? You follow? But it's not difficult. You do progressive logical reasoning. Does that make sense? Okay? When you have this, okay, the idea is to get rid of one square root symbol at a time. You corner one of them at a time. It means you put one on one side, the other one. In fact, if it was like this, square root of x minus square root of x minus square root of 2x plus 5, okay, equals 3, you have to take this guy over here before you square it. Do you understand? Do you follow? Abdullah, what did I just say?
Why?
I'm telling you, that's how you solve the question.
Oh.
Yeah? You follow what I'm saying? Why do I have to find the slope of the line if I want to get the equation of the line? You know what I'm saying? Okay. What? Listen, Omar. When you have, like this problem, when you have variables with square root symbols on both sides, you deal with one at a time. You corner one at a time. You take them on one side and then square it. Okay? You follow? Now with this 3 though, if you take it over here, it doesn't matter. Because then you have 3 on this side. If you take it on that side, it'll be on that side. It's the same. You follow? Bismillahirrahmanirrahim. So the approach is to isolate one of them, like this, and square it. Now look what happens when you do that, okay? Then you have to FOIL this. There's no way around it. Remember I told you when we did FOIL stuff and that, you can't get away from it, so might as well learn it. You can't get away from factoring, you can't get away from foiling, okay? Okay, so you're going to have to FOIL this thing. X minus 3
Like a double FOIL.
times, what? So times square root of x minus 3. What happens with this one?
Same exact thing.
This disappears. Yes?
Oh, because there's nothing outside.
Right. So this one I got rid of, right? You follow. Okay. Now I have to FOIL this. First, what's square root of x times square root of x? Okay. Outer. Minus 3x times this? Minus
3x squared.
3 square root of x. Inner.
3.
And negative 3.
Negative 3 square root of x. Very good. Last.
Plus 9.
Plus 9.
When you do this, like, why is the like equation like backwards? Shouldn't it be like, that?
X squared of x times 3.
No, like, when we learned it was a minus b squared is a squared plus 2ab minus b squared.
No, it was not.
It's not.
It was not.
Oh.
Oh, because 2x plus 5. You got it? Do you understand? These are like terms. So you have x minus 6 squared of x plus 9 equals 2x plus 5, right? Yes, sir.
Why isn't it positive 6? Because isn't there 2 negatives?
No, you're adding them.
It's negative 3 and then square of x and then negative 3.
That's minus 3. Negative 3x minus 3x.
Minus 3 square root of x minus 3 square root of x. Did I do it right?
So why isn't it positive 6?
Because you subtract. It's like minus 3x minus 3x. What is that? Yes, yes, yes. Yes? You-
Oh, okay, okay,
You,
okay. Oh, okay, okay.
you understand?
Yes.
Okay. Okay, now watch. Okay, I'm going to simplify. Okay, I'm going to simplify, okay? Okay, I have an x here. I'm going to take it to the other side. Okay? That's gone. So minus 6 square root of x plus 9 equals x plus 5, okay? I have a 9 here. I'm going to get rid of it. I have negative 6 square root of x equals x minus 4. Right? Right. Now I'm going to square it. Right. Then I'll get rid of this. You can do this, you get 36. 6 squared is 36 times x. You can now have to FOIL that in quadratic, okay? X squared minus 8x plus 16. Now this is a quadratic equation that we know how to solve. I gave you a bad example, it's kind of too complicated. But that's how you do it. After the inshallah, agree.
But that's the final answer.
No, it's not. You have to solve for x. It's a quadratic equation that you know how to solve, right? So x squared minus 8x, okay, plus 16 equals 36x. You have to bring this over this side, okay? So x squared minus 44x plus 16 equals 0. Then you know how to solve this quadratic equation. You can solve it that way. Do you understand this? So the idea is to isolate one at a time. I didn't give you. I made this one up, so it kind of didn't turn out so good. But that's the basic principle. Maybe we'll come back and do one that is not so difficult. Okay. After until then, I still have to go somewhere. So I'm back. So I can.